Section 10.3 is where you're going to find the areas of regular polygons. So if you remember, a regular polygon is where you have congruent sides and all of the angles are also congruent. So this is just showing you that we're going to, you can circumscribe a circle about any regular polygon, which means that you can put it on the outside of it. It says the center of a regular polygon is also the center of the circumscribed circle. So what that helps us do is we can try and figure out what these angles are on the inside by using the fact that a circle always adds up to 360 degrees. The radius of a regular polygon is the distance from the center to the vertex, so from there to there. The apothem is the perpendicular distance from the center to a side. The reason why that's important is because you're going to use the apothem here in a little bit to find the area of a regular polygon. So the first problem is not too bad because you're just finding some angle measurements. So here is my picture, and it's wanting me to find what the measures are for angle 1, 2, and 3. Well, angle 1 is this angle measurement from here to there. So that means that I want that section of my pie, if you will, because remember we're going to use the fact that the circle is circumscribed around it. So that means that all of these angles have to be 360, while all of those angles are also congruent to each other. So I could take 360 and divide by how many sections I have, which are 5, and figure out what each angle is. So that means that angle 1 would be equal to 72. The next thing I could do is, if I know that this big angle is 72, the apothem, which is this line that they drew perpendicular to the side, I know that it will bisect that angle. So I can take 72, divide it by 2, and that will give me angle 2, which is 36 degrees. Now, to find angle 3, I know that this angle is 36. I know that this angle is 90 because it's an apothem. So since I have 2 of the 3 of my triangle, I could take those 2, subtract it from 180, and find my missing angle measurement. So your third angle would be 54. Okay, pause the video and see if you can do it on the got it question. So in the got it question, they're giving you a regular octagon. So that means to find angle 1, you would take 360 and divide by 8. So angle 1 should be 45. Angle 2 would be when the apothem bisects that angle, so it would be 22.5. And then you would take 180, subtract away 22.5 and 90, and that would give you your remaining angle 3, which is 67.5 degrees. Okay, so the last note that it just put on there was that if two figures are congruent, then it should make sense that their areas are equal. That's really not mind-blowing there. But the next theorem at the top of the next page is our formula of how we're going to find the area of a regular polygon. And that formula says that I need to do 1/2 times the length of my apothem times the perimeter of my polygon. So there's a couple of things that you have to have. You have to have the perimeter and you have to have the height or the length of the apothem. Okay, so here is my first picture. It's giving me a regular decagon. So a decagon is going to be 10 sides. So I need to know the length of my apothem. Well, they gave it to me from my picture. It's hard to tell because this should say 90-degree angle there. So they already gave me my apothem, which is 12.3. I can find my perimeter very easy as long as they give me a side length. So since they gave me this side as 8, I just took 8 times 10 or added up 8 10 times, and so your perimeter should be 80. So all you should be doing is just plugging in those numbers. So I would do 1/2 times 12.3 for my apothem times 80 for my perimeter, and I would get 492 square inches. Pause the video and see if you can do the got it question. So in the got it question, they didn't give you a picture. They just said the area of a regular pentagon with an 8 centimeter apothem and 11.6 centimeter sides. So wanting to know the area. Well, they gave me the length of the apothem. My perimeter, all I would need to do is take 11.6 times 5, and that would give me the perimeter. So I did 1/2 times my apothem, which is 8, times 58, which is what I got for the perimeter. So your area should be 232 centimeters squared. Okay, The last problem. In problem 3, there was a honeycomb that said it was made up of regular hexagonal cells, and the length of the side is 3 millimeters. It's asking for the area of the cell. So what I did was I drew a hexagon, and I labeled that each side length was 3, and then I started to draw out each central angle. So I did 360 divided by 6 since there were 6 sides. So that means each central angle was 60. And since I need to find my apothem, I am splitting this apothem in the middle of my central angle. So that means that this angle would be 30. So if I blow up this triangle a little bigger here, you'll see that this angle inside here is 30. And then since my apothem is splitting my side length, I know that for this triangle, it would be half of my side length, which is 1.5. We need to find this side of the triangle, which is your apothem. So we're going to use trig functions to make it easy for what we're doing. So I have from my angle the opposite side and adjacent side. So the trig function that uses that is tangent. So I'm going to do tangent of my angle, which is 30, equal to 1.5 over a, because it's the opposite over the adjacent. Since the a is on the bottom, I'm going to flip these two things to solve for a. So this is where we took 1.5 and we divided by the tangent of 30. And when you type that in, you should be getting a decimal, which would give you 2.6. So my apothem is this number. Now I need to find my perimeter. My perimeter is just my side length times how many sides I have. So I'm going to do 3 times 6, which is 18. Now I'm ready to just plug everything in. So I have a half times my apothem, which is 2.6, times my perimeter, which is 18, and then I round to the nearest tenth. So I get 23.4. So now pause the video and try the got it question. So same scenario in the got it question. You still have a hexagon, excuse me. Side length is 16. So you're going to split into your central angles again. So when I split into my central angles, I see that I have 6 of them. So I'm going to do 360 divided by 6. So that means that all of my angles are 60. My apothem is going to split that angle. So when I draw out my triangle, at the top of my triangle, it's going to be 30 because that's half of 60. My apothem gets to split my side length. So that means down here at the bottom, I got an 8. And then my apothem is that height piece. Same thing as before, we have opposite and adjacent from our angle. So we're going to use tangent to find our missing side length. So we're going to do tangent of 30 equals 8 over a. A is on the bottom again, so you want to flip-flop these. So on your calculator, you should be doing 8 divided by the tangent of 30. And your apothem should be 13.9. We now have our apothem. We need our perimeter. So I'm going to do my side length times the number of sides. So that's going to be 16 times 6, which is 96. And then I'm going to plug in all of my stuff. So a half times my apothem times my perimeter. So you should be getting 667.2. Or if you round to the nearest square foot, like the directions said, you would just do 667. So that concludes finding the area of a regular polygon.